a second. Let me check and see what question we have coming off of here. Maybe, if I can figure out how. Okay. I'll just watch for a chat. If you guys see a chat thing at the bottom, yell at me, okay? I'll send this. Compound inequalities, so part B of our lesson. The second section of our lesson. Let's say I give you something like this. This is stuff when we have more than one restriction. This is on page 128 if you're following in your text. This is when we have more than one restriction on X. So sometimes I may have more than one kind of thing I'm talking about, where I have to use those intersection rules we did before, the intersection or the union. And sometimes I'll just have them all sandwiched together. The sandwich ones are my favorite, but we'll look at everything. Let's say, for example, we had 2x less than 6 and 3x plus 2 greater than negative 4. It's like two separate problems, isn't it? You guys can already do this, basically. I mean, except for maybe the very last graphing. So I'm actually going to add to this. I'm going to say, go ahead and solve and graph, because in this problem, I want to make sure we actually know what the solution is. The other ones, I feel pretty confident you could have graphed those. Those are what you would have expected. But let's go ahead and solve the left one. To get x by itself, what do I do? Okay, same thing both sides. Does anything happen to my sign, or is it fine? Okay. Remember, even though I've kind of, every problem except one has been fine, that's not always the case. You will come across problems where you do flip, so watch out for that. Looking here at this one, I want x by itself on the right, so I'm going to say minus 2 on both sides. Nothing has changed. Even though I'm using a minus 2 on both sides, why do I not care? Why does it not flip? I'm not multiplying or dividing, right? This is just a regular subtract. That doesn't hurt anything. It's only multiplying or dividing. So be really careful with that. 3x greater than negative 6. Now I'm going to do my multiply or divide. I'm going to divide by 3 on both sides. And x is bigger than what? Negative 2. Now wait a second. We had this statement, and we have and connecting the thing. What's that mean? Back when we learned our intersection stuff, is that the union where it takes everything, or is that the intersection where it's being picky? There's an N in the and. Maybe that'll help you.
A union?
So it's not a union, it's actually an intersection. And you can use the word, or there's an N in there, just like for intersection. Because basically the way it works is it's saying, I want this and this. I'm being picky. This solution has to satisfy both sides. You know, like if you had somebody really picky that's like, you know, maybe you had a kid or something, they go into the store, I want a red shirt with stripes. Or I want my shirt to be red and have stripes. They're being more specific than saying, I want a red shirt or striped shirt. You see what I'm saying? When you use the or, you're being more liberal. You're saying, I'll take more stuff. I'll take everything. But with the and, you're saying, I'm being pretty explicit on what my expectations are. I want this and this all together. And you can think about it because the and is like the upside down bucket. So when I graph this thing using the intersection, let's remember how we do that. Question on the computer. What is it?
Is or, and then the word or, that's everything, right? Then if and is the upside down bucket, then or is the right upside bucket, right?
Yeah, that's a good comment. So I'm going to actually ask you guys too. Carmelita just made a point on the computer. She said, if the intersection, if and means the intersection, what does or mean? What does it make sense that the or would mean, the more liberal one? The union. It's going to be the basket that collects everything, and that's what she also pointed out. So yeah, that's exactly right. The pattern will be that when you have or, it's the one that takes them all. It collects everything. This one or this one will make it happy, so we'll put it all in the basket. So that's a good thing to go ahead and note here. So when we're graphing this one and we're using that intersection, we're going to say, you know what, x is less than 3. So just for change, just for kicks, I'm going to use the parenthesis bracket thing, just to make sure, I don't usually do that a lot. So let's see, with less than, it would have been an open circle or a parenthesis, right? Okay, so that's what I'll use. And which way am I coloring, left or right? Okay, so parenthesis, color left. And then for the other one, I have still no equal, so it's going to still be open or parenthesis on the -2. And it colors this way. And for the and, remember, am I looking for where it overlaps, or am I just looking for everything in the world that it has? Where it overlaps, good. So I'm looking for everything where it touches. Oh, look. That means that even though really that 3 right here went left forever way past that parenthesis, and even though that -2 technically kept going forever way past that 3, I'm only keeping where they overlap right here in the center. That's the only part that I'm going to keep as my solution, because it had to make both of them happy, this one and this one. So just this part here, I'm going to actually stop the arrows and just say, you know what, it's just this center part here, because they both had to be happy. AKA, they both had to overlap. And that's parentheses. I know it kind of looks funny. Okay, good. We'll get to some with an or in a second. I don't actually see one right now. Hold on. Actually, yeah, I do. Let me skip ahead a little bit. This is still close to the same section. Let's say we had an example like this. And once again, we'll say solve it and graph it, just because I want to make sure you guys can do that you can represent it on a picture and talk about the answer. So solve and graph your solution. So in this example, we have 2x plus 3 greater than 7, or 4x minus 1 less than 3. You guys go ahead and solve that for me, and then we'll discuss the or part in a second. Okay. On the left, what are you guys getting? X what? Okay. X greater than 2 is what you get when you do the work. And what do you get over here? Less than what? 1? Okay. And we had an or. So nothing has changed as far as the process. You saw this one on the left by itself, this one on the right by itself, and you get these two statements. The only difference, though, is that or means something different to us, doesn't it? That means we're being liberal. We're taking anything because we want this or this. So, okay, let's draw the picture and take everything. So we have a 1, we have a 2. Let's see, x is greater than 2, so that's going to not include the 2, but it'll go to the right, correct? And x is less than 1, so not including the 1, going to the left. What kind of answers are okay for this number? What am I keeping for my final answer? Everything, basically, except the only thing I'm not taking is a number in between 1 and 2. Anything else will satisfy this relationship we put up. Anything else is okay, because I only had to make one of the two happy. So notice, only numbers between 1 and 2 are not accepted. And actually it's between, but including. Because notice how it's like a parenthesis. On the 1 and on the 2, that's saying it can't be equal to 1 or 2. And including 1 and 2, not accepted. Everything else is A-okay, though. 1.2 is okay. Wait a second, is it? No, it's not. Negative 1.2. Because 1.2 is exactly in the middle of there. Everything except stuff between those. Decimals, fractions, we don't care what it is. It's just whatever. We take it. Okay, good. Now let's look at one where we've sandwiched it in between. And we'll see what you guys think should happen. So here's another example. This is actually kind of like an and statement, because here I'm saying x is in between these two numbers. And on the number line, remember how when it's in between two numbers, it's kind of like an and? I mean, that's how it would associate. But we don't have to care too much about that right now. The idea is, how would I handle this thing? What do you guys tell me? What are your expectations? If you do something in one place, where would you better also do it? Every single side, okay. So if you want to get x by itself still, what's around the x? 1, okay, so subtract 1 and take it away everywhere this time. That's kind of what makes sense, and that's exactly what you do. Subtract 1, but do it everywhere, on all sides of this thing. So negative 3 minus 1 gives me negative 4. Does my sign flip? No. I'm going to write everything down straight below it. 5 minus 1 gives me. Now, I have a question for you guys. What if for some reason I multiply or divide by a negative? I do it everywhere, right? What would happen to my sign? It would both flip. Perfect. You'd have to go ahead and flip them both. Yeah, very important. If I had multiplied or divided by a negative at any point in this problem, they would both flip, both sides. And I'll give you an example in just a second where that does happen. Okay, but for right now, we're going to divide by a positive 2, right, to get x by itself. And we know that's okay. Nothing has changed or messed up. So we have negative 2 is smaller than x is smaller than 4. Can you guys graph that? 2. Yes, if I could divide, it would be helpful. Oh, well. So let's see, on the number line, what's that look like? Negative 2, 1, 2, it's in between the two things. So we have, when I graph this, by the way, I like to have the sides pointing that way if the x is in the middle, just because then all you do is you put it on the number line and sandwich it in between. It helps it be easy. Notice something else for me. When you're solving these problems, see how both arrows are pointing the same direction? That will always be like that. It doesn't matter which way they're pointing. They will always point the same direction. If not, you have a broken problem. Something has gone very wrong. Because x is sandwiched in between. One has to be bigger than x and one has to be smaller than x. It's the only way you can write it in a string like this. So when I graph the answer, I'm going to say negative 2, 2, and it's everything in between. That's my answer. So I just graph it like it reads. X bigger than negative 2, okay. And at the same time, x smaller than 2. So it's a really cool way to write an and statement. That only works if, sometimes if the stuff matches, you can put it together. But otherwise, you can't do that. How are you feeling? I'm going to modify one of these